number 47 gives you y equals 3 times 1 minus sine x divided by 2 cos x. And it asks, find the derivative of the trigonometric function. So, I guess there's an easy way and a hard way to do this. The easy way is to make any kind of algebraic simplification you can first, and then do your derivative. The hard way would be to apply the quotient. So if I were trying to do this, I would probably rewrite this a little bit. Like first I would distribute out the 3. And then because I'm only dividing by one term in the bottom, right, I have a single term down here, I can divide it into each. So I can rewrite this y as 3 over 2 cos x minus 3 sine x over 2 cos x. And then each of these I can transform using my trig identities. So the 3 halves you think of as a constant, but then you kind of have like a 1 on top here being multiplied. So you have a 1 over cos, which is equal to what? Secant. And then the 3 halves here are again constants out front, but then sine over cosine is tangent. So you can rewrite this as y equals 3 halves secant minus 3 halves tangent. And then if you remember, we talked about trig derivatives, right? We know how to take the derivative of, let's see, sine x, tan x, and secant x are the regular non-co functions, right? So if you just have these guys that don't have a co in front, all the derivatives are positive. What happens to sine? Cos when you do the derivative, tangent. Secant squared when you do the derivative, and secant tangent when you do the derivative. If you do the co-functions, then you get negatives. You have a similar pattern, but you get negatives in front. But this is all we need for these. So now I can actually calculate the derivative by doing y prime equals, the 3 halves is a constant multiple, so when you do your derivative, just bring it down. And then focus on the secant. Derivative of secant is secant x tan x. Minus, again, constant multiple, derivative of tangent. So this is one form of the answer. You could probably do a lot of algebra and change this into different forms. Maybe you guys would rather just do the quotient rule. Maybe the quotient rule would be faster for you. I don't know. Kind of depends. Depends on how good you are with your trig identities. Where'd you get stuck at?
Well, I just erased what I did now, but basically I distributed first, and then I did the product rule at the top.
Oh.
And then I tried to do the quotient rule, and it just was all confusing.
Other questions? Here's a quiz.
28.
28 on 2.3. Find the derivative of the algebraic function x to the 4th times 1 minus 2 over x plus 1. So they give you a function, I guess they call it f of x. x to the fourth times 1 minus 1 over x minus 4. Oh, x plus 2 over x plus 1. And then we have to find the derivative. Okay. I don't know. How do you guys want to do the derivative here?
We can turn the inside the thing to x minus 1 all over x plus 1.
If you want. Yeah.
That's one way.
That's one. That'll be something. So you have. At the beginning, though, you have a choice. Are you going to do algebraic simplifications, or are you just going to try to apply the product? Okay. I wouldn't start with the product rule here, because then you're going to have a quotient inside of a product, so you're going to have to do quotient rule inside a product rule, and it's going to be kind of ugly. So I would definitely try to simplify this a little bit first. One way is to get a common denominator here, although that doesn't actually make your life too much easier. Definitely distributing will be helpful. This will be f of x equals x to the fourth minus 2x to the fourth over x plus 1. Now, if you want to get a common denominator here, you can, and if not. It doesn't really matter. But when you do the derivative now, you can do the derivative of this guy, and you can do the derivative of this guy, and subtract. So for this guy, you would have to set up a quotient. There's really no way around it. So I would set up my top function as f of x, which is 2x to the fourth. My bottom function, g of x, is x plus 1. Then you do the derivatives of both of those. F prime of x is equal to, what's the derivative of f?
8x to the power of 3.
8x cubed, right? You drop the 4 down and then subtract 1 from the power. And then here, g prime of x, well, that's just 1. Right? Derivative of x is 1. And then all of this gets divided by the g function squared. Right? After you, sorry. You have to multiply like this, right? Multiply up, multiply down, and subtract. And all of that gets divided by g squared. And so that's how you get the derivative of this, and then this guy you can do separately. So f prime of x will equal, let me do this guy while I'm at it. The derivative of x to the fourth is 4x cubed. Minus, because I'm just copying down this minus, then I have to actually apply my quotient rule here. So this whole thing I'm going to do quotient rule to, which will give me 8x cubed times x plus 1. Minus f times the derivative of g, so 2x to the fourth times 1. Over g squared. So 4x cubed minus this entire fraction. Let me clean this up a little bit. This will be 8x to the fourth on top, plus 8x cubed, minus 2x to the fourth, over x plus 1 squared. Yeah, these guys will combine to give me 6x to the fourth. Because I have 8 of them and 2 of them. So 4x cubed minus 6x to the fourth plus 8x cubed all over x plus 1. This is 1 answer. You could get a common denominator by multiplying by x plus 1 squared over x plus 1 squared, I guess. You could factor out an x cubed here, 2x cubed. There's a bunch of things you could do algebraically, but this is
about a question.
Question
So,
about questions.
Yes,
Okay.
I don't have like an exercise that I need help with.
Yeah, I understand.
If someone is asking you to find if there is a horizontal,
Tangent line.
like tangent line, or a vertical, how can you just in general find it? Do you use the derivative or?
So the general answer to your question, a horizontal tangent line occurs when the slope of the tangent line is 0.
Okay.
So to find a horizontal tangent line, you have to set the derivative equal to 0.
And then you'll see how many points.
I have an example I'll do for you.
Oh, please, thank you.
Yeah. It was part of the review I was going to do from 2.3, so
Thank
I'll do it eventually. But let me finish homework questions.
Cool. Yeah.
Anything else I can do for you from the homework?
Number 9, if you don't mind.
2.3?
Hi.
Square root x over x plus, or x cubed plus 1?
Square root x that I keep screwing up.
Mm.
Forgetting how to do that.
Yeah, I hate those square roots. Definitely hate those square roots. Y or F? Oh, they call it H. Okay, H of x. Use the quotient rule to find the derivative of the function. Okay, so they tell us to use the quotient rule, so we better use the quotient rule, or else Larson will be pissed and try to beat us. So I'm going to go ahead and set up my top and my bottom. F is the top. F of x equals root x. G is the bottom. G of x equals x cubed plus 1. Now, when you actually derive here, you're going to need to rewrite this. Okay, when you're taking the derivative of the square root, you want to rewrite it as what?
X to the half.
Yeah, the square root is the 1/2 power. So before you do any derivatives here, I would rewrite this square root of x as x to the 1/2. Then you can do the derivative pretty easily, I think. Right, the 1/2 comes down, and then it becomes x to the negative 1/2 because you have to subtract 1. Right, this guy always comes down. And then you have to do this exponent, which is 1/2 minus 1. 1/2 minus 1 is negative 1/2. So there's f prime. Then we do g prime. Yeah, the x cubed becomes 3x squared, and then the constant 1 goes to 0. So our quotient rule says we multiply these two. We multiply f times g prime, subtract. So I'm going to write it over here. H prime of x equals. So I'll do this guy times this guy. Let's leave it as a negative 1/2. So 1/2 x to the negative 1/2 times x cubed plus 1 minus this guy times this guy, root x times 3x squared over g squared. So this is the derivative with no simplifications whatsoever. Although we could simplify this a little bit. Let's simplify this just so we get used to seeing some of this algebra here. On the top, I can distribute out my 1/2 x to the negative 1/2 here. And here I'm going to turn this into an x to the 1/2 and combine these exponents. So what do you think is going to happen here? So if I distribute this guy out, I get x to the what?
5 over 2.
5 halves, how'd you get that?
6 over 6. 6 over 2 minus
Yeah,
5
you change, you get a common denominator, you have to do 3 minus 1 half, right? So 6 over 2 minus 1 half is 5 over 2. And then the negative 1 half goes here. I mean, x to negative 1 half goes here. And then what's this exponent going to be?
Plus
This is a 1 half exponent. This is a 2 exponent. So when you add those, because you're at, since this is positive 1 half, you're going to add them. What are you going to get?
5 over 2.
X to the 5 halves again. So this guy and this guy can combine. Since they are like triangles.
Negative 5 over 2.
Yeah, so again, you have 1 half and 3, which is 6 over 2. So if you do 1 half minus 6 over 2, you get negative 5 over 2. So you have to add these two, negative 3 and 1 half. So you get negative 5 halves, x to the 5 halves, plus 1 half, x to the negative 1 half, over. And then the only other thing, one other,
This problem.
you guys are gonna have, you're gonna have to learn how to deal with negative exponents eventually. Do you want to learn it now, or do you want to just leave it? Okay, that's fine. It's partially simplified.
Yeah,
Well, but not just this guy though.
right.
I mean, if he would go down, but he wouldn't go down here because this is under the whole thing. So one way to do this, to make the negative 1 half go down, is to factor it. Factor out a 1 half x to the negative 1 half from the top. So if you pull out 1 half x to the negative 1 half from this guy, you're left with just 1. But the tricky part is pulling it out from here. What happens when you factor out a 1 half x to the negative 1 half from here?
Negative 5 times x to the power 5.
Times x to the power what?
Hold on. Negative 5.
This?
Yeah.
What happens when you check this if you do this times this?
It's going to be 5 over 2.
You get a positive.
What happens to exponents when you multiply? You add them.
Add 'em, yeah.
So if you add negative 5 and negative 1 half, do you get 5 halves? Try again. Neg?
6 over 2.
Yeah, 6 over 2. How about 3?
Yeah,
That's what I would try.
that's what I meant.
Because negative 1 half plus 3 is going to get us back to this 5 halves. So let me say that again. When you factor, like normally, right, if you had 3x squared plus 2x cubed and you factored out an x squared, what would you have left? 3 plus. Now, how did you get this x? How did you get this exponent? You subtracted, right? You took 3 and you subtracted 2, and you got 1. So over here, what you have to do is take 5 halves and subtract negative 1 half. 5 halves minus negative 1 half is 6 halves. Then this guy can be flipped down in front of this. So you can rewrite this in its completely simplified version. Again, if I do not tell you to simplify, you've you've taken the derivative here. Right? This is the derivative. The instruction just said take the derivative. That's the derivative. But if you want to try to make it as simple as possible or match the book, or I say simplify, then you want to multiply everything out, and then if you have negative exponents, you have to factor those negative exponents out so that they can be put down. In chapter 3, we do a lot of this, okay? So it doesn't hurt you to start looking at it now. Well, maybe it does hurt you, I don't know. Maybe you're like bleeding now. Stab you with my negative exponents.
Where did the 2 square root of x come from the denominator?
What's this equal to? X to the 1/2 is the same thing as square root, and then the negative puts it down.
Yeah, okay, thank you.
And then the 2 was in the denominator here, so you can put it in the denominator here instead.
I don't even remember that.
Okay. Let me do some of these problems. Get to the chain rule, the best rule. Some review. Differentiate each function. Y equals x squared plus 1 over 7. How do we take the derivative here? Do you need quotient rule here?
No, pull out the 1 7.
Yeah, quotient rule would be a pretty big waste of your time. When the bottom's constant, right, like this is just a constant 7, there's no x in it, you can rewrite it with a 1/7 out front times x squared plus 1. And this is going to be a lot faster to differentiate. So if the bottom is constant, I would pull it out as a fraction like this, and then I would do my derivative. Since this is a constant multiple, it can stay in front, and then you just do the derivative of these guys.
2x.
2x. Right, derivative of x squared is 2x, derivative of 1, 0. So y prime 2x over 7. However, if I give you this, then what? Then you have to switch. There's no choice. So let's do it. I love the quotient rule so much. So use it all the time. F is the top. So it'll be just the function 7, constant function 7. G is the bottom. Do the derivative of each. Derivative of f. What's the derivative of f here?
0.
Derivative of a constant is 0. Derivative of g?
2x.
2x. And you multiply up, multiply down, subtract, and divide by bottom square. So in this case, y prime will equal 0 times this guy, which doesn't do much, minus 7 times this guy, over x squared plus 1 squared. So negative 14x over x squared plus 1 squared. bottom constant, you can pull it out, save yourself a lot of heartache. Top constant, got to do. Okie dokie. So what if I gave you y equals cube root of x times x minus 5? Should we product rule this bad boy?
Yes.
No.
But rewrite the x first.
No product rule.
What the?
You can do the product rule, but I wouldn't. Right? I would rewrite this cube root of x as x to the 1/3, and then distribute, right? Because it's really not that much work to distribute. Now, what do we get when we distribute? This is 1/3 power. This is the first power. 1/3 plus 1.
4/3.
4/3. Minus 5 x to the 1/3. And then we can do the derivative without any special, just power. So what do we get?
4/3.
4/3 x to the, you have to subtract 1 from the power, so
1/3.
1/3 minus, and 1/3 will be 2 times the 5. So 5/3 x to the negative 2. Or 4/3 x to the 1/3 minus 5 over 3x to the 2. Get rid of your negative x. So that's probably a little faster than the product rule. Probably, I don't know. Depending on who you are the product rule. Maybe you guys are product rule ninjas. Bust it out. So, what if I give you h of x equals sine, let's do it like this, x squared times sine x. Can you multiply this x squared in here, make this sine x cubed? Oh God, no. So what? So you have to do product rule here. There's no choice.
2x and then
Yeah. So your f of x is x squared, which means your f prime is 2x.
the plus cosine.
Your g of x is sine x, which means your g prime. Cos x, derivative of sine is cosine, and you crisscross. So you'll get 2x sine x. Two x sine x plus x squared cos x. So this one we couldn't simplify, we couldn't rewrite in any way. We had to do our solve.
We good.
One more. So what about y equals x tan x over x cubed minus 1? I could change the tangent to sine over cosine if I'm thinking about rewriting this, but that's not going to make my life any easier, right? Because I'm going to have a sine on top and a cosine on bottom. That's even uglier. So rewriting this, as far as I can tell, there's not many options. So then I would go in directly to my what rule? Quotient or product? If there's a product on top,
Quotient.
start with the quotient, because that's, remember we talked about this outermost operation idea, right? You would evaluate this product before you would do this division, right? So you start outside, you do the division first, so you do the quotient rule first. Inside of the quotient rule, you're going to have to deal with the product. But as it stands, I have an F and a G being divided, so I can do quotient. So f of x is x tan x, right, the entire top. And g of x is x cubed minus 1. All right, this one depresses me, so I'm going to start here. G prime of x is equal to 3x squared. All right, I feel good enough about myself to try and do this one now. It's all about self-esteem. So, this is a product, which means I have to do the product rule on this. Okay? So, I don't know, maybe you can do it without setting up your table. What do you think?
Set up a
Nope. Nope. So the way this works is you're going to break this up into another f and g, or whatever you want to call it, u and v, or whatever. And you're going to have to do the derivative of the first times the second. So the derivative of x is 1 times the second tan x. And then you reverse it. You add, but you keep the first one the same, x, and you times by the derivative of tangent, the derivative of the second. So then this whole monstrosity would have to get multiplied by this guy. This whole monstrosity, it's not that big actually, but this guy would have to get multiplied by this guy. Because it's quotient rule, you're going to subtract. Divide by g. So the derivative equals, let's see if I can fit this. So we got to do tan x plus x secant squared x times x cubed minus 1, like this. This product minus this product, x tan x times 3x squared over g squared. So x
I look at it.
ended up boxing. Yeah, I wouldn't try to simplify this too much. About the only easy simplification you can do is multiply this x and this 3x squared. That would be pretty easy, but otherwise I would leave it. So 3x cubed x. If you did FOIL it out, you would get a little bit of cancellation. But, it was way too much of a headache. Definitely leave it at this. So how do we feel about these product rules inside quotient rules?
They're great.
They're great. They're wonderful, right? They're so amazing.
Yes.
All right, once we get the chain rule today, then we'll have a quotient rule inside of a chain rule. Inside of another chain rule. Oh, what is a chain rule? Oh, what is a chain rule? That's what you are going to find out very shortly. But I want to, because we talked about horizontal tangent lines, I want to do one example of horizontal tangent lines. Then we'll do chains. So last review. Determine points at which the function has a horizontal tangent line. And I'll give you f of x equals x minus 4 over x squared minus 7. Okay, so if you're trying to find when something has a horizontal tangent line,
Trying to find where the derivative equals 0.
exactly, right? Because a horizontal tangent line means that you have slope equal to 0. And the derivative gives you the slope of the function. So you take the derivative, which is the slope of the function, and set it equal to 0. So whenever you're dealing with horizontal tangent lines, you're going to set f prime of x equal to 0. No other time, okay? Sometimes students will, I don't know, they'll get used to setting things equal to 0, and so even if it doesn't ask for a horizontal tangent line, they'll set the derivative to 0. That's bad form. I don't want to do that. So make sure you don't start setting things to 0 unless it's asking something about a horizontal tangent line. So that means for us, we're going to have to do quotient rule. I named this function f of x, which is inconvenient, but that's okay. We'll just say h of x. We'll just say top. So the top equals x minus 4. Bottom equals x squared minus 7. So then you do the derivatives. Derivative of the top, just 1. Derivative of the bottom. 2x. So the way my quotient rule works to find f prime, I multiply my diagonals, subtract, and then divide by the bottom square. Okay, I think I can do that. So I have to do x minus, oh no, let me start down here. I have to do 1 times x squared minus 7. Right? F prime of x equals 1 times x squared minus 7 minus x minus 4 times 2x over bottom square, g squared, which is x squared minus 7 squared. Now, that's great. That is the derivative, unless I screwed up somewhere, which I'm sure you'll tell me if I did. But I need to figure out where this equals 0. Right, so I have a little bit more work to do here. So I have to set this whole fraction equal to 0. Wow. Right, so now I come back to this principle. Right, the fact that I'm looking for a horizontal tangent line means I can set x squared minus 7 minus x minus 4 times 2x over x squared minus 7 squared equal to 0. Right, so this is what I have to solve. First of all, you guys understand where this equation came from? Okay. How do we solve this?
We said the top equals 0.
Right, the bottom, so there's 2 ways to think about this. One way is a fraction is only 0 when the top is 0. Okay, you cannot make a fraction by making the denominator 0, because that just makes it undefined.
Mm-hmm.
Okay. So you can make a simplifying assumption right away which says, all right, the top has to be 0. The other way is a more algebraic way of thinking about it. To solve this equation, you can multiply both sides by x squared minus 7 squared. What's going to happen is that'll get rid of your denominator over here. But over here, 0 times anything is still 0. So at the end of the day, no matter which way you slice your pie here, you get the same outcome. The numerator has to equal 0.
So it'd be like, yeah.
And now I would do a little bit of algebra and try to simplify this, right? So for example, let's see here, I have to distribute out my 2x. And I'm also going to have to distribute out this negative. Or I could distribute out a negative 2x. So let's see, I'll get x squared minus 7. And then I'll have negative x times 2x, so
minus 2x squared.
minus 2x squared. And I'll
Plus
have
8x.
positive 4 times 2x.
Plus 0. And it's negative 2x squared.
Yeah, let's collect like terms. Negative x squared is x
8x.
squared minus 2x squared. Plus 8x
Negative 7.
minus 7.
0.
So you have a quadratic equation to solve. Oh.
So, can we like do x?
First of all, I hate that negative. That negative's freaking me out right now. Quadratic formula. Get out of here with the quadratic formula.
So we write a x squared minus 8x plus 7.
All right, so I'm going to get rid of this. You can either multiply both sides by negative 1, or you can factor it out, but let's just multiply.
Yeah, like 7.
Times negative 1 times negative 1. That just flips all my signs. So this is going to end up being
x squared.
x squared minus 8x plus 7, which is factorable, which you're all going to factor this. Get rid of your quadratic formula garbage. This is x minus 7 times x. You can use
No,
quadratic
plus. No, minus, you're right. Never mind. Don't believe me.
Yeah, so you can factor or use the quadratic formula, okay? If you factor, it's pretty quick, and you get x equals
7 or 1?
7 or 1. Now, it depends on how picky I feel like being, but you didn't technically answer the question yet, right? Because the question said determine the points at which the function has a horizontal tangent line. You determine the x values.
So now we need 1.
Right, so for the points, you have to come back here and plug in x equals 1 and x equals 7 and find the y value for it. Right, to take these x values, and turn them into points, you have to plug back into the original function. So over here, to get your points, you have to find f of 7 and f of 1. F of 7 is 7 minus 4 over 7 squared minus 7. 3 over 42, which reduces
1
over 14. F of 1 will be 1 minus 4 over 1 squared minus 7. So negative 3 over negative 6, or 1/2. Which means these are your y values. So then altogether you will have the points.
Oh, and then
You'll have the points here. When x is 7, y is 114. So there's 1 point. And then when x is 1, y is 1/2. So these are the 2 points on the graph for your function as a horizontal tangent.
that's it?
That's it? You want more?
I thought we need to keep going and do like y minus 1 of the
No, when do you do
values
that?
To give the tangent line.
But did it ask for it?
Oh, okay.
Yeah, it doesn't say find the equation of the tangent line. First of all, it's a horizontal tangent line, so the equation would just be y equals 1/2 and y equals. But it didn't ask for the equation, it just asked for the points. Be careful, or you'll be doing more.
Yeah, well,
More work
that's
than
my
you have to
mistake.
do.
I was the same mistake.